Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 15.5, Problem 10. This is Section 15.5, Problem number 10. It says, find the area between the function f of x equals x to the third, shown in red, and g of x equals 4x, shown in blue. So just to be very clear, what's red and what's blue, the x cubed is in red, and the 4x is in blue. So whenever we need to find the area trapped between two graphs, we do a definite integral. What makes this one a little bit different is that area is pinched off into two separate regions. So we have to find region 1, keep track of the area, then do region 2, keep track of that area, then combine those two answers. So in general, when we do a definite integral like this, we want to do the integral of the top graph minus the bottom. I'll include a dx with that. And we can do them in either order, the two regions of trapped area. I'll just go right across left to right. It makes sense. You could do the upper right one first and just figure you're going from the top to the bottom. That makes sense too. However you want to do it. So the upper graph is x cubed. It's up higher than the straight blue 4x. So x cubed is the top, minus 4x is the bottom, dx. Now I need to know my limits of integration. And the limits of integration come from the points of intersection where the red and the blue graph intersect with each other. Well, one area where they intersect is 0, 0. That one's easy. But the other one, if you read it off the graph, especially the graph printed in the homework, this point of intersection is back 2 and down 8, -2, -8. So my limits of integration come from the x coordinates of the points of intersection. The 0, 0 doesn't matter if you get the x and y mixed up, but the other point of intersection, -2, -8, will make a difference. It has to be the -2. You want the larger of the two values as your upper limit of integration. 0 is larger than a -2, so 0 is the upper limit. -2 is the lower limit. So I have a definite integral that I need to solve. It's a 4-step process to solve it. First, solve the integral. So the x to the third has an integral of 1/4 x to the fourth. Then minus 4x, you can think of the 4x as a 4x to the first. It's minus 4 over 2x to the 2, which I can simplify as 1/4 x to the fourth minus, instead of 4 over 2x squared, make it 2x squared. And of course there is a plus c with that. The c for constant would cancel by the 4th step, so I don't bother to write it. It is in there, but it doesn't need to be written. I put a long vertical line after my answer for the integral, and in the vertical line I put my limits of integration, the 0 on top and the -2 underneath. So the next step is plug in the upper limit of integration, the 0. So I'm going to have 1/4 x to the fourth is 1/4 0 to the fourth, minus 2x squared is 2 times 0 squared. And because the 0 is very easy, you have 0 minus 0, the answer is 0. So that's the second step of the 4-step process, plugging in that upper limit of integration, get a result of 0. The third step is plug in the lower limit of integration, the -2. Careful of these signs now. So I'm going to have 1/4 x to the fourth is 1/4 -2 to the fourth, minus 2x squared is minus 2 times -2 squared. So careful with your negatives again. So 1/4 -2 to the fourth will be positive 16. And then minus 2 times -2 squared. -2 times -2 is positive 4. So 1/4 times 16 is 4. And then 2 times 4 is 8, but you're subtracting. It's a negative. So you have 4 minus 8 is -4. So now, to finish this definite integral, I take my result of step 2, which is 0. subtract my result from step 3, which is -4. So I have 0 minus a -4, or 0 plus 4, which is 4. So the bottom left piece of area trapped between the red and the blue graph has an area of 4. Now, due to the symmetry of the graph, I strongly suspect that the area in the upper piece is also going to be 4 to give me a total of 8. If you don't realize that, do the definite integral again, or you may suspect that it's symmetric and would have the same answer, but you're not 100% certain. So if either of those is the case, you can just do it again. So same process. You're going to have pretty much the same work going on. You're going to do the integral of top minus bottom dx. Now that upper right piece here, the top graph now is a straight line. That blue 4x is now the top minus the bottom. In this half of the graph, that curved red graph, the x cubed, is the lower part. It's not as high up on the graph. I'll put the 4x minus x cubed in parentheses, put a dx in the end. I need to figure out my limits of integration. One limit of integration is going to come from the x-coordinate of the point 0, 0, where the two graphs intersect. You have another point of intersection here. And on the homework, it's easier to read than my freehand graph on the board. It would be over 2 up 8. And again, it's the over 2, the x-coordinate, that matters. The up 8 doesn't matter for your limits of integration. So one limit of integration is 2. The other limit of integration is 0. The larger of those two values, the 2, positive 2, will be your upper limit of integration. The 0 will be the lower limit. So now I have a second definite integral that I need to solve to find that second piece of trapped area between the red and the blue graph. So step 1 of my 4-step process is solve the integral. The 4x can be thought of as a 4x to the first. The integral is 4 over 2x to the 2. Then the x to the third will have an integral of 1/4 x to the fourth. Again, don't forget it's minus. There is a plus c. I don't need to write it because I know for sure it'll cancel. And I can simplify the 4 over 2x squared. Let me just put 2x squared minus 1/4 x to the fourth. Put my long vertical line after it. Put in my limits of integration, positive 2 for the upper limit, 0 for the lower limit. So the next step, step 2, is plug in the upper limit of integration into my answer for the integral. The 2 goes in for x. So 2x squared becomes 2 times 2 squared, minus 1/4 x to the fourth becomes 1/4 2 to the fourth. So I'm going to have 2 times 2 to the second is 4, minus 1/4 2 to the fourth is 16. 2 times 4 is 8. 1/4 times 16, or a fourth of 16, is 4. So 8 minus 4 is positive 4. If that does wind up being the answer, but to really do it right, you're supposed to plug in the lower limit of integration also, which is super easy to do. It's no reason not to. Put in your lower limit, the 0 for x, so you'll have 2x squared becomes 2 times 0 squared minus 1/4 x to the fourth is 1/4 0 to the fourth. It's clearly 0 minus 0, which is 0. Finish the integral to the end. The step 2 result of 4 minus the step 3 result of 0. 4 minus 0 is 4. So sure enough, as I had suspected, the upper portion of the graph is also 4. So I have 4 from the lower left, 4 more from the upper right, add 4 plus 4 more. The total area between the red graph and the blue graph is 8.